So hi, good morning, everybody. In our French time, and good afternoon in Indonesia. So I'm Dewanti Chaningsi, and I will be the moderator of today's workshop. So all of the participants, welcome to the workshop to STATA for various empirical studies in finance, banking, and accounting. Organized by the Center of Fintech and Banking, Universitas 11 Maret, as the part of series World Class Professor, a grant held by the Ministry of Education, Culture, and Republic Indonesia through the Director of General of Higher Education, Dikti. So this program provides an opportunity for the National University in Indonesia to connect it with a high-class professor to improve the productivity of research of the academic member of the university. So before we start our session today, our second workshop, let's meet our three instructors who already prepared the material to you on STATA. So let's meet our first instructor, Professor Siong Hock Lau from University of Putra Malaysia. Hi, good morning, Professor.
Yeah, hi. Yes.
It's good to see you, and let's also meet our second instructor, Bapak Tastaftian Ristwandi. Halo Pak Andi, apa kabar?
Ya, baik. Hello everyone.
And also, last but not least, let's meet our third trainer, Mas Aldi Faris Asanta, PhD student and also the researcher from the LAPE, Université de Limoges, France. Bonjour, Mas Aldi.
Hello, bonjour.
It's always good to see you. We already have a 72 participants joining in this event. And before we start our session, let me invite the chairman of the Center of Fintech and Banking, Universitas 11 Maret, Dr. Irwan Trinugroho, to deliver the remarks. So, Pak Irwan, selamat pagi dan apa kabar?
Baik, Mbak. Terima kasih.
Dipersilahkan, Pak.
Okay. Yeah, so thank you, Dewanti. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, yeah, thank you very much for the three trainers from the today workshop. Professor Xiong Lo, always with us. Yeah, always happy. And then the second one is Pak Andi. Apa kabar, Pak Andi? Pak Andi is my junior colleague at the Faculty of Economics and Business, UNS. And the last one is Mas Aldi. Mas Aldi is he was my assistant a couple of years ago, but now he is more than myself. He is now a PhD student, last year PhD student and researcher at the laboratory. I forgot the abbreviation of the laboratory. So the name of the laboratory is Lab of the University of Limoges. And also for all participants, thank you for joining today's workshop. So today's workshop is the second workshop from the WCP programs of the Center of Banking and Finance in the UNS, with the particular focus on the use of STATA for empirical studies in finance, banking, and accounting. So next week we still have one more workshop which is dedicated for discussing the how to get published in good journal or something like that. Okay, and I think we will have also international doctoral colloquium in collaboration with the doctoral programs in economics of the UNS in the beginning of October. I think still have plenty of time to submit the paper if the participant they want to submit paper, because we collaborate with a number of journals and very good lineup of collaboration with the journal. So if you have paper or if you have at least abstract or proposal, you can submit to the doctoral colloquium. It's not mandatory to be a doctoral student to participate in this event, so everyone can join. Yeah, I think it will be in 6th of October. Okay, so I think that's all. So without taking so much time, so I think I enjoyed the workshop, and hopefully the workshop will be beneficial for all the participants. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. So thank you very much, Dr. Irwan, for the remarks. And as Dr. Irwan said, without further ado, let's meet our first instructor. The trainer for today's is the first trainer is Professor Siang Hoklo. He is currently a professor in economic department, University Putra Malaysia. He holds a PhD in economics for the University of Leicester, United Kingdom. He also the editor-in-chief for the International Journal of Economic and Management. So Professor Siang Hoklo, you will be given 45 to 1 hour to deliver your material. So without further ado, please present your presentation. Thank you.
Yeah, thank you. So, yes. I think I will share my slide first. So, yeah, salam sejahtera. And then a very good afternoon, everybody. So, yeah, Bapak, Ibu-ibu dan Bapak-bapak sekalian. So, I would like to share my slide. Yeah, I think I need to share the screen. Yeah, this is my screen, then share. I hope everybody can, yeah, I enlarge first. Yeah, so today the topic is, yeah, I also focus on the panel data because normally when in the area of banking, finance, I hope everybody can hear me, because it's loud enough, or else I will adjust my volume. Let me adjust first my volume until 90%. Okay. Yeah, I think better now. So yeah, when you do in the area of banking, finance, and accounting area, then we need to deal with the panel data, especially the company data or the firm level data. So today I would like to share with you how to analyze this data. Besides using the dynamic panel GMM estimator, so the other method proposed by the Peterson, also can be considered, because based on Peterson 2008, he said different researchers, they use the different method to analyze the data, and then he used the multi-color simulation. Then he found that due to the standard error problem, therefore he tried to propose to correct for the standard error, so that our t-test, especially the t-statistic, is robust and is able to conclude our conclusion, our hypothesis. So this is the review. So panel data analysis in empirical finance, banking, and accounting, and consequences of bias standard error, because due to the standard error problem. And then what are the practical approach for testing panel data in the area of finance, banking, and also accounting. So we need to test for the firm effect, and holding the time effect constant mean that we hold no time effect, but only for the firm effect appear. So the firm effect mean the firm have the specific effect, or sometimes they call as a fee effect. But I do not want to use fee effect, because later might confuse the fee effect and also the random effect. So I use the firm specific effect. So different firm, they have the different characteristic or heterogeneity. Then the second is test for the time and also the firm effect, mean we take into consideration of both. Time effect and also the firm effect. Together we need to test whether these two effects appear in our data set. If let's say we have these two effects, we need to control for these two firm and also the time effect. And we want to estimate the standard error in the presence of the fee effect. Like I mentioned to you, is a firm specific effect, the fee effect here, and the time effect, right? So the learning goal is to explain the consequences of bias standard error in empirical research, especially if let's say your area in banking, finance, or accounting. And then you have one model one to estimate, and to identify the correct method to estimate the panel data. And then we want to discuss the standard error in the presence of the firm specific effect and also the time effect, and estimate panel data using the STATA software. So the empirical research in finance or accounting or banking frequently involve analysis of the panel data set, the firm level or company level, plus some macro data. There are few paper, not few. I saw many paper. They combine the company level data and our macroeconomic data. So in corporate finance, we typically encounter panel with large cross section. Mean the company is large, but the T is small. But in the area of asset pricing, mean we want to look at the, let's say the stock market, the asset pricing, the prices. Then we deal with the long time series panel, large T, but the number of firm may be less than the T. So mean the T is a long time series period. And in this data set, the residual, I mean the error term may be correlated across the firm and also across the time. So therefore, due to this auto correlation or serial correlation, then the affect the error term, because due to the error term is correlated, then this will affect the variant, mean the variant is not a minimum, therefore the standard error also biased. So the OLS standard error can be biased because over or underestimate the true variability of the coefficient, mean the beta 1, beta 2, or beta 3, we want to estimate can be biased, mean they cannot represent the true parameter of the population. Yeah, so this is the problem when the residual may be correlated across the firm or across the time. So this is the major issue that we need to correct so that our result is unbiased. So for example, this is the effect of the gearing on the abnormal return. Yeah, I take this example from these two authors, a paper published in the International Business Review. Yeah, you can see the model, the dependent is CAAR, cumulative average abnormal return. Then they have the independent gearing, the psi. Then the MB is the ratio of the market to book ratio, and the PE is the ratio of price to earning. Then the interest rate is the macroeconomic indicator, and the risk is the market risk. So this is the model used by these two authors, and the sample consists of the firm from the 1965 to 2008. So the firm is got many firm listed in the London Stock Exchange. Then they estimate this model. Okay, so you can see that it's IT. IT is have the panel data, mean the firm and also the time. So we have this 1965 to 2008, the time series component. The second example is whether the foreign or domestic bank react differently to business cycle and banking crisis. So a paper published in the Journal of Banking and Finance. Yeah. So the model can see that GR is a percentage credit or market share, a growth of bank I in year T. And then they have the independent, they have takeover and Greenfield, the takeover and also the time invariant. Yeah, it's a dummy, it's a, yeah, and also the Greenfield dummy. And then when it's dummy, then you can see only have I, no component T, yeah, because it's a dummy, right? Then after that, we have the crisis is the metric of the crisis related variable, crisis dummy, and the interaction term. So when you have the dummy, and then you can interact direct with the other variable, which is the discrete or have the number, the value is the number variable. You don't need to include another crisis as one of the independent variable. When you have interaction, you can direct, interact the dummy and also the other variable. And again, the control for the macro indicator and also the other control variable. So they have this specific effect, the mu I. So the sample is a Central and also the Eastern European country, 250 bank. Yeah, so this is the second example. The third example, I think this one related with the accounting, the determinant of compensation. Yeah, so a paper published in Journal Accounting Research. So yeah, you can see the dependent is the changes of these annual percent changes in the cash compensation of the director, excluding the CEO. Then as a function of EPS, earning per share changes, and RET is the annual stock return. Then they have the growth is the annual percent changes in the turnover. So this is the three example that we can see how the literature apply in the how they estimate. But according to the Peterson, I will share the paper with you. don't worry, then you can read the Peterson paper. Then you can estimate the model, more accurate. Not mean that you did not follow the proper criteria. So why using the correct method to estimate standard error is very important, because if standard error are biased, then making our conclusion based on this standard error is inappropriate. Because normally we use the T and also the F test to make our conclusion, right? Whether they are significant or not significant. You know the T test is equal to the coefficient then divided by the standard error. So the standard error, of course, is from the variant. If let's say we have the problem of the serial correlation, mean the residual they are correlated, then the variant no longer minimum, then the standard error also no longer the minimum, standard error. So mean that the t-test mean if let's say the standard error is no longer minimum, then you divide with the big value, then the t-test coefficient divided by the big value, then our t-test will be very low due to we divide with the standard error, big standard error. Therefore, the t-test will be go down very small t-test because the standard error is high. Yeah, then the t is small. So this is the result when you have the incorrect or inappropriate standard error. So when you have this problem in terms of hypothesis testing, normally the small t will fall into this acceptance region. They cannot fall into the outside here, the rejection region. They always fail to reject the hypothesis now, where the now show that no relationship. So we always conclude there is no relationship between the A and B. So what we have tested all show no relationship. But whereas in case if let's say they have the really relationship exists, then we make the wrong conclusion due to the standard error, they are biased standard error. So the small t-test will always fall into the always less than 5%, let's say 1.96, then always less than 1.96, the t statistic. Then we make the wrong conclusion to test our hypothesis, because we always fall into the acceptance region in this acceptance, but it's not outside the rejection region. So yeah, we have the model, mean that the beta, the hypothesis now, the beta equal to 0 mean no relationship between x and y, and alternative beta is not equal to 0, there is a relationship between x and y. So when you fail to reject the now, mean that we always conclude no relationship between x and y. So all we have tested the variable no show any sign to show they have a relationship. So if the t-test is small, due to the standard error bias, then we fail to reject the hypothesis now. We conclude that no relationship between x and y. So this is the issue, the problem. So our conclusion here, no relationship between x and y. So how about if x and y indeed they have a relationship? Mean that they have the relationship, mean we have tested the wrong procedure, mean that our result is not reliable. So when analyzing the panel data, our empirical evidence is summarized almost exclusively in terms of the t-test of the coefficient of the interest in the panel regression. So accurate computation of the t-test is important because it depends on or subject to the accuracy of computation of the standard error. So despite the common use of the panel data in the finance, banking, and accounting, there is a wide variation in the method used to estimate the standard error. So according to Peterson, actually it's 2008, so it's not 2005. So I will send the Peterson paper to Dr. Ivan, so he can share to everybody. Yeah. So yeah, so due to this issue, so how to correct the standard error is very important here. So researcher has used different solutions to adjust the standard error among the procedure are the fixed effect or within group estimation, then the GLS and OS adjusted for the correlation within the cluster. Yeah, so this is the method used by the researcher. Then after that, we have other method as well. So we have pharma-McMill procedure. The pharma-McMill procedure require the time dimension about 30 year or 30 year of observation. Run later explain to you what is a pharma-McMill procedure. Then we have the Nemi-West procedure to address the issue of correlation of error term and also the white standard error. This one also want to address the issue of correlation within the cluster. And how to select the correct procedure. Since we have 1, 2, 3, 4, 5, 6. So which one is the best? So yeah, so these are the few estimator you can consider. So when you report the result, yeah, so this is the paper. This one is from the Peterson 2008 paper. So you can see 1 until 5 model. So they use the different standard error. What standard error? Cluster by firm, cluster by time. Then they include firm effect or firm specific effect and time effect. And so the last one is based on the Farmer-Bagbell procedure. Of course, the Farmer-Bagbell will require you to have the more T observation. So okay, so how to select the correct procedure is very important. So two general form of the dependent serve as the basis for the analysis. So the two general form can guide us. So the first one is unobserved firm fixed effect, a firm specific effect, mean the residue of the given firm may be correlated across the year for a given firm. Means same firm, but the firm different year error term correlated. Yeah. So only one firm, but the firm their residual are correlated. And the second one is the time effect. Mean the residue of a given year may be correlated with other year across the different firm. Yeah. So I'll show you these two examples later using the diagram. So example, the first one, the firm level data, mean the residue of the given firm may be correlated across the year for a given firm. Mean the firm itself, they correlated. Mean for example, the residue, the epsilon 1,1 correlated with the epsilon 1,2 and epsilon 1,3. And then for the third firm, the Brahim firm, also the residual correlated. So this is the first case. And the second case is based on the year, the time. You can see for the year 2000 for the first firm and the year 2000 for the second firm, mean the epsilon 1,1 correlated with the epsilon 2,1, then correlated with the epsilon 3,1. Mean the year 2007, they have correlated across the firm. Mean the residue of the given year may be correlated across different firm. Yeah, so we have the time effect. So this is the example, yeah, the two important effect. So the question now, in the presence of the firm effect or firm fixed effect or firm fixed specific effect. So let's say the correct estimator is OLS standard error cluster by firm. So we should use this one to produce unbiased result. Yeah. So the example, if let's say you detect you have the firm fixed effect or firm specific effect, then you need to regress using the full OLS, the normal regression, but you need to put the robust cluster by then the firm. Let's say your panel data, you use the firm as an ID, or you use the code as an ID. Yeah, later I will demo to you. Then the other one, OS, New US, White, Test, and also the Farmer Bell procedure, they are biased, so we cannot use this estimator. So what you can do is just regress, normal regression, dependent, independent, comma, robust cluster by the firm ID. Yeah, so when you detected the firm has the firm specific effect. Yeah, so of course we can test later whether the firm have this effect, yes or no. And in the presence of the time effect, the correct estimator, you can either use the Farmer Bell procedure. If let's say the T is large, let's say you have 30 year, 30, or you can use the other or standard error cluster by time. So based on the Farmer background, you need to install the command xtfmb, dependent, independent, then the VRB or SE, then they will come up the result for you. Or you can use the OLS standard error cluster by time. Yeah. So you regress, dependent, independent, then comma, robust cluster year, due to there is a time effect. Yeah. So these are the procedure. How about if let's say both effects are present? Yeah, in the present of firm, fixed effect and also the time effect. So we need to address these both together. So yeah, you can see the first, you can regress the Y, then the three independent, you can control with the time dummy. If let's say you only have 10 years, you can put 9 dummy. You cannot put the 10 dummy, otherwise we have this dummy trap. Then comma robust cluster by firm or code. If let's say the T is very small T, 10 year or less than 10 year, and then the firm number of firm is large, let's say 100 firm. Yeah, so I better you control the time, include in the regression, and the robust cluster by firm. Okay, mean the small T, large N, we prefer use the number 1. If let's say you have small n, large T, then I will swap, mean that the regress, the Y, X1, X2, X3, then I'll put the firm dummy, robust cluster the year. Yeah, when your year is last year, many year, let's say you have 20 year, then you put the year here. Okay, you no need to put the year 1, year 2, year 3 in the first one, because for the first one it's a small t, large N. For the second is a small n and large T. Yeah, so it depends on your data set. So what is robust mean? Is most general construction. This robust model, they more stable and reliable model. So they treat to stability and so reliability include the outlier, heteroscedasticity. Mean that when you put this robust robust command, they can address the issue of this outlier or heteroscedasticity. Mean the error term do not have the constant variance, mean they have the non-normal residual. So the robust option may relate the assumption of this classical linear regression model that the error IID, or why we put the cluster to relate the assumption that the error are independent of each other. Yeah. So okay, so this is the cluster. We can read what is cluster mean. Yeah, because due to the time effect, yeah, the time constraint, I cannot yeah mean I need to, yeah, we move to the next one. So example, how to test the presence of the firm specific effect or firm fit effect. You can refer to the, the previous, yeah. Of course, you can use a Houseman to test, but actually you no need to use the Houseman. Also, you can identify. For example, I use the XTIG command. XTIG is the panel regression, is to test for the free effect or random effect command. Yeah, so I use XTIG. The dependent is Tobin Q. Yeah, and then the three independent, no, two only. Yeah. Then I put comma, free effect. Then this result will appear. Then you observe the last row, the F test. The F test is a joint test. They joint test the the intercept, whether they have the same intercept, yes or no. Mean that they show the p value, the F test, the p value. The p value is 0.001 example. So you reject the common intercept. When they reject the common intercept, they have the different intercept. Mean that the firm, they have the different intercept. Mean that the firm, they have their own characteristic, or the firm have their own specific effect. Yeah. So actually, you no need to test using the Houseman. You can use this procedure. You just look at the last row, the F test, and see the F statistic, and also the P value. As long as the P value is less than 0.05, then we can say that they reject the common intercept, mean that they conclude they have the different intercept. When they have different intercept, mean they have the specific firm fixed effect, because each firm they have the different intercept. They are not sharing the same intercept because they reject the common intercept. Yeah. Then we can confirm that the firm has the firm specific effect, or fixed effect is present. All right. So the procedure 1. Then come to the procedure 2. We want to test whether the firm, how to test the presence of the firm fixed effect. We need to generate the time dummy variable using the, I think this is to how to test the presence of the firm time effect. Yeah? Not the fixed here. Later I will change. The slide 22 is the firm time effect. You need to generate the time dummy for the firm. Then you regress, yeah, the Tobin Q, then include the time dummy. I say I have 10 firm, I just include the 9 firm. 9 time dummy. I cannot include 10 time dummy, otherwise I have this dummy track. So you can see the dummy and dummy 2 and dummy 3 until and dummy 10. And then you can see whether they are significant. Yeah. So we can join the time dummy, join test whether is there any time effect present. So I test at the dummy, the end dummy. Oh, okay, sorry. Actually, this one is still the firm fixed effect, but I use the command, but we use the second procedure. Just now, the procedure 1, we just look at the last row of the F test. Okay, for the second procedure, whether to test for the firm specific effect, mean that we generate the firm dummy is correct. We generate the firm dummy is not the time dummy. Yeah? This is N refer to the firm, T refer to the time. So mean I generate the time, no, the firm dummy. N refer to the firm. So I have 10 firm, then I put the 9 firm dummy. Then I include the 9 intercept here, the 9 firm intercept. Yeah. Then I restrict this, the intercept from 2 until 10. So I test using the normal test the joint test. So N dummy 2 until N dummy 10. So they give me the result 15.84. And the P value still the same. You see the 15.84 actually is the same with the first procedure. This one. Yeah, 15.84 is the same F statistic, and so the P value also the same. Yeah, so this is the second. So I think maybe you like the procedure 1. You no need to generate the firm dummy. You can direct observe whether it's significant or not significant. It's significant means show that there is a firm specific effect appear. So you can see here the same test statistics, same F value, and the P value also 0. So this is the hypothesis, the common intercept for all firms. We support the POLS. If they reject the hypothesis now, mean we support the fee effect or the firm specific effect, yeah, the alternative hypothesis. So if let's say the P value is less than 0.05, reject the null hypothesis, common intercept mean that all firms have their different intercept. When they have different intercept mean the firm have their own specific effect. Yeah, so either procedure 1 or procedure 2, I think it's up to you. You want to test for the firm specific effect appear or not. Yeah. So I believe everybody like the procedure 1 is more straightforward. Yeah. Compared to the procedure 2, you need to generate for the firm dummy. Okay. And then come to this time effect. How to test the presence of the time effect? Because we need to test for the firm effect, time effect, then we can decide which estimator you want to use. Yeah. So we need to create the time dummy. So you regress with the time dummy. So the time dummy because I have 5 years. So I put 4 dummy in my regression. So and then you can see the time dummy 2, 3, 4, 5. And you can see the t-test for the time dummy and also the p-value. So it seems that all the p-value are greater than 0.05. When you joint test a time dummy, I don't think they were significant, right? So I try to test the joint test for the time dummy. Of course, when you need to, how to create the time dummy, in our STATA, you need to tabulate the year. If let's say the time is you use the year, then comma, generate in the bracket, and normally put the T dummy. So in the bracket, you can put any name you like, but I prefer put the T dummy to indicate this is a time dummy. Yeah. So this is the way how you generate the time dummy. After that, we join test for the time dummy. Just test time dummy 2, 3, 4, and 5. Then you can see that the F test is 0.77. The P value is greater than 0.05. So mean that no time effect. Yeah. So because why? The hypothesis is no time effect. The alternatives have the time effect. And this one, the P value is greater than 0.05. Mean that we fail to reject the hypothesis now. We support no time effect. Yeah. So we support no time effect. Time effect is not required in the model. Then in this case, we only have the firm specific effect. You no need to test for the time effect. Yeah. So therefore, we need to use the slide 17, only have the firm effect. Yeah. So mean that you use the cluster. So I mean, for example, so you need to use the slide 7. I go back the slide. Yeah. So let's say in the presence of the firm fee effect, then you can use this regress, dependent, independent, comma, robust cluster by firm or code that you indicate in your STATA. Yeah. All right. So you use this one because no time effect, only firm effect. Okay, so we direct go to one example. The example, the data is also available. Yeah, I sent to Dr. Iwan. You can request from Dr. Iwan. So it's the finance firm Tobin Q in the Excel file. So you want to estimate this model. The dependent is Tobin Q. Then as a function of size, the debt, the agency cost, the growth. So this is the independent variable. So the data is obtained from the Bursa Malaysia, and then 200 firm, yeah, and the time period is only 6 years, 2005 to 2009. I think it's 5 years, 6 years, 5, 6, 7, 8, 5 years. Okay, 5 years. So yeah, so 5 years, 200 firms. So we want to estimate the model using the correct standard error method. So of course, you need to test whether this data set has the firm specific effect, also the presence of the time effect. Yeah. So first, you need to test the firm specific effect present. So okay, first we need to transfer the data from Excel to the STATA. We just copy and paste. I can demo to you later if you have time. Then after that, we indicate the panel data setting. You can use the XT set, firm and year. Yeah, I use the firm as ID to represent the firm and the year as a time. Then this will come out from the STATA. It says it's a strongly balanced panel data. Then I generate the time dummy because later I want to test for the time effect. So tabulate the year, comma, generate, then you put the T dummy, TDUM. Then the output will have show you the 2005 until 2009 because we have 5-year dummy. So next we want to test whether they have the firm specific effect. Before that, because just now we say the correlation across the residual, right? In the error term, they are correlated. So I can use this XT serial command to prove that is there any serial correlation. So we need to install this XT serial command to test the serial correlation. So I use XT serial to win Q dependent, sign that agency cost, grow, then output. Then you can see the Woolrich test here. The Woolrich test, the auto correlation mean that they reject the p-value is less than 0.05 and the null hypothesis, no first order, auto correlation. So mean that they reject the no auto, conclude that there is an auto or serial correlation. So mean that it proves that the firm data set, they have the auto correlation or serial correlation among their residual. So there is a serial correlation problem since the p-value is less than 0.05. So yeah, we have this serial correlation problem. Then we cannot simply use the OLS estimator to estimate the model because that one will be biased. So therefore, you need to control for the firm and so for the time effect. So prove that we have the problem. So now I want to test whether the firm has the firm specific effect. Yeah. So I use the procedure one. I just XCIG, the dependent, and I list all the independent, comma, FE. Yeah. So this is the fit effect. Yeah, model. So yeah, the fit effect within the regression. Then the Tobin Q is the dependent. Then these are the independent sign, depth, agency, cost, growth. Then the normal way how you can interpret the result. You can see the P is, let's say, less than 0.05. The significant one only agency cost. Yeah, only one variable here. But this is based on the fit effect. Then how do you conclude whether the firm has the firm specific effect is present? So you look at the last row, the F test here, yeah, the F test, and the F statistic is 20.23 and the P value is 0.0000. So what can we conclude? Is there the firm specific effect appear, or is the firm specific effect present? Yes or no? Anyone want to respond? Yeah, you look at this one. So F test is significant, mean that we have the firm specific effect. Mean that yeah, we need to take into account that the firm have their own intercept. They cannot share the same intercept. Yeah. So how about the time effect? We still need to test. We need to generate the time dummy. Yeah. So we test for the presence of the time effect. Then we need to generate for the time dummy. Since I have 5 years, I put the 4 time dummy in the model. Then I regress only. Yeah. For when you want to test for the time effect, the presence of the time effect, you cannot use the XTREG, just regress only. Or that's the normal regression, the POLS. You cannot use the XDIG and put the time dummy because the XDIG, the within peak effect, they will take the mean and then the time dummy will disappear sometimes, yeah? Yeah, so therefore just regress, Tobin Q, sign debt, agency cost and growth. Then you can see the time dummy, yeah, you can see, then attach to join the time dummy 2, 3, and 4, and 5, then the result of the test for the F test is 0.0000. Yeah. So what do you conclude here? So we have the time effect, yeah, is present since the p-value that is less than 0.05. Yeah, so we have the two effect, the firm specific effect, then the time effect. So mean that in this example, this data set, we have two effect, the firm specific effect and the time effect. Therefore, we need to use the slide 19 to address the issue because yeah, they can help you to estimate the unbiased result. So we need to use the appropriate method. Yeah. So the above result indicate the presence of firm fit and the time effect, a firm specific effect, and the time effect. So we can address the time effect and then estimate the standard error cluster by firm. Yeah, so you regress, Tobin Q, and also the independent variable. We need to include the time dummy and then comma, robust cluster by firm because I use the firm in my panel data set. The firm, the code, I use the firm, the ID, I use the firm, then I use comma in the bracket robust cluster firm. Yeah. So this is the result that you can report because you can see the standard error now is a robust standard error. So the standard error adjusted for 200 cluster in firm. So the Tobin Q, you can see this is the dependent. Sign is significant now, debt not significant, agency cost significant, and the growth is not significant. So now two variables significant. And the time dummy, they are significant. We need to control for the time effect. Yeah. Yeah. So you can report this result as your final result. Yeah. Okay. Because we have addressed the firm peak effect and so the time effect. So let's say only one peak effect, firm specific effect, but no time effect. This is the example. It's just to demo to you in case you detected one effect only firm specific effect, no time effect. So you can regress a Tobin Q independent variable, comma, robust cluster firm. Yeah, this is your final result because you only have the firm specific effect. Yeah, you can refer to page 17, only have firm specific effect. If only have the time effect, yeah, let's say if there is a time effect, no firm effect, specific effect, then the appropriate method is a Farmer-Maxwell. If your data observation is about more than 30, 30 year or 25 year and above. So you can see the Farmer-Maxwell procedure. So the Farmer-Maxwell method has been used extensively in the analysis of the cross-sectional stock return. So the Farmer-Maxwell procedure, they have two steps. So in the first step, they run each time period, let's say year 2000. In year 2000, 200 firm, they run one regression. Then they collect the beta one. Then in year 2001, they run another equation and then they collect the beta one. And then in year 2002, 2002, they run the cross-sectional 200 firm regression, then they collect the beta one. So mean that they will take the average of the beta one. So mean in the second step, the time series of this estimate to obtain the final estimate for the parameter and then the standard error so that the t-test can be computed. So okay, so later you can see how this pharma background work in the STATA. So let's say you have the time effect. So you can use the pharma background procedure. So this is the command XTFMB, the dependent, independent, and BERBOSE, the command. So this is the pharma background standard error, the result. So 1, 2, 3 significant, but you need to take note. This is only 5-year period. Yeah, it's not so enough for you to estimate using the pharma background procedure. Yeah, I mean that for year 2005, they have one beta for the sign that agency costs grow. And for the 2006, they year by year, they take 1 year to estimate the cross-sectional data. Then they have the coefficient, beta 1, beta 2, beta 3, beta 4, until 2009. And then they take the mean for this 5 year. So you can see 0.118 is the size, 0.1189 here. And then the t-test, significant, not significant, right? And for the debt as well, is 0.355. So the debt is 0.355. They take the mean for this 5 year. So mean that the 5 year is not sufficient. If let's say you have more year, then the result will be more reliable. Yeah, let's say 25 year, then they take the mean for this 25 year, then the coefficient will be more accurate, more reliable, yeah, based on the pharma background procedure. But anyhow, don't worry, it only 5 years we still can use the other method. Use the least square, the one that I showed to you, the one that you just control, I think page 18, the slide, page 18, you can control the time effect. All right, they compare the least square using the OLS request command, and also the pharma background. According to this Scholarkey, they suggest that pharma background method or procedure is suitable for a large time dimension, the T. Like I mentioned to you, the T, let's say you have 20 year or 25 year above, more year, then will be better result. But both OLS and the pharma background procedure, when you apply properly, they have the comparable performance, mean the result are reliable, equally reliable, they are t-tests. So since these two approaches are justified under very similar assumptions, researchers are encouraged to use both approaches, mean that if your T is large, you can use the pharma background. At the same time, you can use the OLS regress, then a cluster, robust cluster with time, yeah, with time, because there is a time effect, no firm specific effect. Yeah, so then you can report the result. The model 1 is our result. The model 2 and 3 is the one that I assume only have firm effect, and model 3 I assume only have time effect. But the model 1 is our main result, because in this data set, we have the firm effect and also the time effect, yeah. Then you need to report the coefficient, and so in this paradensis, they are the standard error. And also whether put the 1% or 5% the star here. So the model 1 should be interpret in our final result. But model 2, model 3 is just demo to you in case you have the firm effect model, also the time effect. Yeah? So please ignore the model 2 and 3 because our data set showed both effects are present. Okay, yeah. Then you can see just focus on model 1, interpret model 1. Don't interpret the model 2 and 3. All right. So you can do some other robustness check using other estimator. Yeah. So using the various standard error, like example, the white standard error, GLS or random effect, feasible GLS, panel corrected standard error. Yeah. Okay, so I would like to highlight here, you need to install the reg2 command so that you no need to transfer the STATA output using, you type the new result, because this command can transfer the output directly to your Microsoft Word or Excel. It depends on you prefer the Microsoft Word, but I use Microsoft Word lah. Then they will direct transfer to the result in the nice table. Then you no need to retype again, but you need to install this command. So how to install? You just SSC install our IG2 in your STATA, then they will install this command for you. So how to apply? I mean, after you estimate the model, then you type RIG2 using. You must type using. If not, they cannot transfer the result to your Microsoft Word. RIG2 using any name you like, then .doc. You must put .doc, otherwise they couldn't identify which whether the Microsoft Word or any other the software, you know. So you put .doc, then they will save all the result in the column by column. So let's say you have 1, 2, 3, 4, these 4 estimator, then you have 4 model, then they will add 4 column for you. The white standard error, GLS, feasible GLS, and also the panel corrected standard error for you. So you additional 4 column as a further robust check. So you use, then you look at the white standard error, the command. So you need to request turbine Q, then the sign, the other independent, and then put the time dummy, since the time effect is present, and comma VEC robust. So this is the white standard error command. Then they show the result. Then you can see the size significant, the depth significant, the agency cost significant, the 3 variable significant, but the growth not significant. And then the time dummy, yeah, significant as well. Yeah. So VEC specify the types of the standard error reported, then are robust to the some kind of the misspecification. So right, then after that is the GLS or random effect. So you can use XTIG, terming Q, dependent, then independent, comma, and I, then the firm. Then they'll show you the GLS result. It's a random effect GLS regression. So you can see now the size significant, but the depth not significant, agency cost significant, the p-value, as well as the p-value less than 0.05, then will be significant, 5%, growth not significant, and the time dummy significant, because we detected there is a time effect present. So this is the second. And also the GLS or random effect, you can use another command, cluster by firm, I firm, then cluster by firm. So they have a slightly, but the coefficient is still the same, but the standard error is a robust standard error. Yeah. So you can see the different result now when you use this cluster firm, the GLS. Yeah, only the agency cost significant, right? The other side significant at 10%. All right. Then the other one is a feasible GLS. But this test require you, the T must greater than N. Mean your time dimension must greater than N. Then you can use the XTGLS, the feasible GLS. So the feasible GLS standard error are robust to error term. Yeah, no heteroscedasticity, no serial correlation. Yeah. And however, the XTGRS is typically inappropriate for use with the medium and the last scale of panel due to the at least 2 reasons. Mean the method is infeasible if the panel time dimension T is smaller than the cross section. Mean that they require T must greater than N. Yeah, let's say you have 30 here, and the N only 20 company, example. And this method tend to produce unacceptably small standard error estimate sometimes, So therefore, when you want to use the feasible GLS, make sure the T is more than N, okay? So if you try, in my case, my T is 5 years, but N is 200, so it's not advisable to use the XTGLS, yeah, because in my example, I have 200 firm, but I only have 5 years, so N greater than T. But I just want to demo the command for you in case you want to apply your data is suitable. Yeah, so it's X2GLS, dependent, independent, then you put the dummy, time dummy, then this is the feasible GLS result. Yeah, of course, not reliable because our T is small, yeah, but you take note lah, yeah. Then the final one is a panel corrected standard error. So to overcome the problem of this feasible GLS, Beck and Carl, 1995, they suggest to use the panel corrected standard error, PCSE. Yeah? So you have the PCSE standard error are robust to disturbance being heteroscedasticity. And also they have the serial correlation AR1, first order autocorrelation. Yeah, they can address the two problems together. Yeah, so the common XTPCSE, dependent, independent, and put the time dummy, then you can report this result. Then finally, you can summarize in one table using the REG2 command. Then they will summarize in the table for you. Yeah, result for a robust check using the various standard error. So the model one, we use the white standard error. Then you use the GRS or the random effect, but random effect cluster by firm, FGLS, PCSE. You can see I did not report the pharma bell due to our T is small. Yeah, so we just transfer the result using the RIG2 command. Then you can have the nice table. Then you can direct interpret the result. Yeah. So now doing research is more faster, since the STATA can direct transfer the result to the Microsoft Word. I think that's all. I think you need to refer to these two important references. The Peterson 2008 Estimating Standard Error in Finance Panel Dataset Comparing Approaches. And the other one is the Cornell 2007 Dealing with the Panel Data in Accounting and Managerial Finance Research, a paper published in the International Journal of Managerial Finance. Yeah, you can, both paper I will email to Dr. Iwan, then maybe, yeah, Dr. Iwan can share with everybody. Yeah, and also, yeah, the other is the paper that I use as the example. Yeah, so I think that's all for my session. Later, yeah, we can have a demo. You have time. And also I want to show you some how to apply, use the STATA, yeah, the hands-on session. But I hope everybody have the STATA program with you so that you can follow the step. Otherwise, just follow my slide, the step, you can get the result as well. Yeah. So I think that's all. So I think I back to the, yeah, Diwanti. Yeah. So I think for me, my session, yeah, end here. But of course, I will continue later. Okay. Yeah. Thank you so much. Yeah.
Okay, thank you, Prof. Lo, for such a very sophisticated and very clear presentation on how doing a panel data analysis in empirical finance. So we also invite all of the participants, if you have a question, you may bring up your question in the chat box. And we already have some question there, so we still invite you. But we will have the question and answer session after the third trainer already present all of the questions. So without further ado, let's meet our second trainer, Pak Tastaftian Rizfandi. He is the faculty member of Fakultas Ekonomi dan Bisnis, Universitas 11 Maret. He holds the PhD, his PhD from the Universitas Dalimos, from Delape also. So, Pak Andi, are you ready? So let's wait. Pak Andi.
Yes.
Okay. Okay, so Pak Andi, you will have around 30 to 45 minutes to deliver the presentation. So time is yours. Everyone enjoy.
Okay. Could you hear my voice?
Yes, it's clearly heard.
Okay. Give me 1 minute. Sorry.
Okay, take your time, sir. So for all the participants, don't worry, we will share all the presentation today to all of you. So don't get hesitate if you have any question related to this event. You will have a chance to deliver all of the questions related to the webinars. And as the chairman of the FinTech Centers delivered to you, it is not the end of the workshop for the world-class professor grant provided by Minister of Education and Culture of Indonesia. We will also have another session that will be informed later. So don't forget to follow all of the information we have through the our social media, LinkedIn, and the other social media. So let's meet Pak Andi. I think he already moved to another place, more quieter.
Yes.
Okay. So Pak Andi, please deliver your
Yes, because
presentation.
I'm looking for quieter place. Okay, thank you. Thank you very much, Dewanti, for the time to me to deliver some materials about STATA and the use in research, especially in finance and economics. And of course, well, what I will say to all of you is not as sophisticated as already said by Professor Lau, because well, actually I'm still feeling that until today, after 2 years of graduating from the PhD, I'm feeling that I'm still a student, and I have to still learn from many people like Professor Lau, Dr. Ewa, and many others, and even from Dewanti or the many others. That well, STATA is, for my opinion, it's one of the very good software that we could use to run data analysis, especially in finance economics. And as my experience that I use STATA, I feel that well, we don't need to be experienced in make a code. Even we are just like ordinary people, we never learn about math. Okay, math is important, but I mean that we don't need to be very experienced in algebra or like that, but then we can use data for the specific purpose that related to our study. Okay, I'm trying to share my screen. Wait, hope that wait, I'm looking for my slides. Okay. Okay. So, well, what I want to discuss with all of you here is that the application of post-monetary recognition, especially if we use data. So Professor Lau already explained to all of us that, well, if we believe that in our data we have fixed effect, or we have some specific effect that is constant over time, and we believe that, for instance, we have data of the firm in Indonesia or a firm in Malaysia, and we believe that in each firm they have several characteristics that differ each other, and it's constant over time. So the fixed effect is most appropriate to be used in our analysis. So recall that if we have this kind of model, so under a strict exogenous assumption, so if we have this kind of model, and we see here there is a y, so under a strict exogenous assumption, so fixed effect and bias. So the fixed effect method is allow for arbitrary correlation between I and the experimental variable in any time period. So okay, so this estimator, if we believe that in our data there is a correlation between, for instance, I have if we run a regression using 5 banks in Indonesia, and we believe that each bank, for instance, Bank Sentral Asia and Bank BNI or Bank Mandiri, they have characteristics that differ each other, and if the performance of each bank, it is related with specific characteristic of each bank, so the FX method is unbiased or it is efficient. But in the other words, if we think that the AY is uncorrelated with each exploratory variable in all time, so using feedback results in inefficient estimators. So if we believe that AY, it is uncorrelated with XIT, X1, X2, X3, and so effect model is most appropriate. So in 1978, Mundell, they said that the random effect model, so they assume exogeneity of all regressors. Assumption all regression have in order their exogenous. But on the other hand, the fixed effect model is for endogeneity of all regression, especially the individual effect. So from here, for instance, so the error term, so we decompose the error term between the fixed error term. So this way, this is EI, and then the time invariant error term, so UIT. So this all or nothing choice of correlation between the individual effects and the regressor. So it makes Hausman and Taylor 1981 to propose a model where some of the regression are correlated with the individual effect and some are not. So this is background why the Hausman and Taylor regression arise. Okay. Well, the resulting estimator, it is called Hausman-Taylor estimator. So this estimator is especially based on instrumental variable estimator. We see how this instrumental variable form in the process of Hausman-Taylor regression. More specifically, the individual means of the strictly exogenous regressors are used as instrument for the time invariant regressors that are correlated with the individual effects. So this is the specification. Well, I hope that all of you could see in your screen. For instance, I have a model. This is the gravity model. You could see from the paper Bufati 2014 that I will put it also in the end of the paper. So this is the example of a gravity model, and in the model there is consists of W and Z. So W, what is W? W is factor of time variant variables. Z is a factor of time invariant variables. So actually in our model we have time invariant variables. The second we have time variant variables. And then in each time variant and in each time invariant there is an exogenous and there is an endogenous. So why in V1 IGT and Z1 IG are assumed to be endogenous. Endogenous means that they are not correlated with an epsilon. And the second, W2 IGT and Z2 IG are assumed to be endogenous. Endogenous means that they are correlated with mu IG, but not epsilon IGT. So how actually Hausman-Taylor is formed? There's a 4-step, but I'm not sure that I could really explain to you today. So I will skip this part, and then we will pass into how this Hausman-Taylor in the STATA. So to sum up, the Houseman terror estimator is obtained using X star as endogenous variable in an instrumentable solution on W star IGT and Z star IG. So W star IGT and Z IGT is the set of instrument. Because this is instrumental variable regression, so similar to, for instance, we know like two-stage least square. Actually, there is a test that should be used to see whether fixed effect estimator or the Houseman estimator are more efficient. Actually, things like that. If our test say that the Houseman terror estimator is not more efficient than the fixed effect estimator, so we have to use fixed effect. So meaning that the result from the Houseman terror estimator is valid, and we can only use that if the result of Houseman test such that the Houseman terror estimator is more efficient. So the test statistics is distributed as chi-square with k mean G2 degree of freedom. So as we see here, K is here, K1 is here. So K1 is time invariant exogenous variable, and G2 is time invariant exogenous variable. So when we use this in STATA, actually we have to set the K1 minus T as degree of freedom. And then under the new hypothesis, the choice of instrument is legitimated and the HT estimator is the most efficient. Okay, so the application, well, the economics transformation of four-step HT could be troublesome for some or most of us, but we no need to worry because statistical techniques such as STATA could perform this estimation using a syntax HTH Taylor. So as displayed in the previous slide, so because in set of variable, it consists of W or time invariant variables and Z or time invariant variables, and its vector comprised of endogenous and exogenous variable. What we do is we decompose our variable, our sets of variable into four: time variant exogenous, time invariant exogenous, time variant endogenous, and the last time invariant exogenous. Why we should do this? The thing is that yes, you will see why we should decompose our model into four of this. So the example, we will use a data of panel study income dynamics that is freely available on the internet. The PSID is the world longest survey in 1868, nationally representative sample of over 18,000 individuals in 5,000 families in the United States. So it is the variables like employment, income, wealth, expenditure, health, marriage, childbearing, and etc. So you, all of us could download the data from this variable free from the internet. So what we do using the PSID data is to estimate the determinant of individual wage of people in the United States. So for instance, suppose that the amount of wage is determined by 12 variables. So how many weeks they have worked, whether they live in South region, whether they live in metropolitan area, whether they are married or not, working experience, and many others. So this is the 12 variable that are available in the PSID that we can use as in our regression. So, well, actually in STATA, this is one of the most interesting thing in that from STATA. So in STATA, if we want to extract the data, we could just using this command, we'll use PSID extract, and then automatically it will come to your software, the data. So we don't need to copy paste into Excel or copy paste from Excel to STATA. If the data is freely available in the internet and the source is provided for the STATA users, so we can only use this command, and it comes to your STATA. And then we can make a descriptive statistics using the command summarize. So for instance, the 12 variable, we put all of them in here, the command you can try, or maybe I can make a simulation if the time is enough. Summarize, big sort, SMSR, and etc. So from this, so we have this descriptive statistics. So the number of observations is, so meaning that there are 4,000 people, and then if we see from here, most of our variables are time invariant. So salt is time invariant, SMSA is time invariant, MS is time invariant, union is time invariant, VML is time invariant. So using we have a kind of data like this, for instance, we cannot observe, we cannot investigate whether, for instance, two women, they really have higher wage compared to men. We couldn't analyze this kind of thing. Why? Because the time invariant data, they cannot be estimated using fixed effect. If we use fixed effect, if it will automatically drop the sample. And then we will face a big problem if the Hausman test suggests us to use fixed effect method. And the next slide is about Hausman test result. And the result suggests that because this is significant, so meaning that in our model with 12 variables we have to use fixed effect methods. And then what we'll obtain if we use fixed effect method. So the result that you could see in your in the right side of your slide of the slide of your screen. So the variable female, black, and education, this is omitted from the analysis. Why? Because this is time invariant. So meaning that we cannot investigate the impact of female on the wage that they have. And then this is also the proof that fixed effect, or FD is actually first difference. It is similar to fixed effect. Works only for time varying regress, not for time invariant regressors, because they already consider our time invariant unobservable factors from the model. So it be a big problem. This 3 variable that is dropped from the analysis is our variable of interest. So it will be a big problem. On the other hand, we could random effect, but the thing is that we believe that each individual, they have time invariant unobservable characteristics. So actually using the random effect, we can justify that we can use random effect in our model. So from this thing, we could see that HT or Hausman terror regression solution. So what we need is that we just need to break down our independent variables into 4 types variable as described earlier. So time invariant endogenous, time invariant exogenous, time variant endogenous, and time variant exogenous. So, and interestingly, STATA will automatically identify which one is time invariant and which one is time invariant. So actually what we will do is just, so we just tell STATA which variable are endogenous, because the STATA will automatically identify which one is time variant and which one is time variant. For instance, suppose that our endogenous variable is experience square, weeks, union, and education. And education, and then the rest are time invariant. Okay, so this is the estimation result. So we obtain a significant effect of SMSA, experience square, union, black, and education. So the variables that in the fixed effect calculation, it is dropped from sample, so it become present here, and therefore we can investigate the effect on the people with. So this regression, for instance, we have several conclusions like people live in standard metropolitan statistical area have a lower wage, higher working experience is associated with higher wage, people who join a union have a better wage, and black people have significantly lower wage. And also people with longer time of attending school have higher wage. So using the fixed effect method, we couldn't have this result. Why? Because this time invariant variable is automatically dropped from the analysis. So this several reading that probably it is useful for you. The first one is target of 2003. It is about the comparison between fixed effect, random effect, or Taylor. And the second one is Bouffatier, 2014. And the third one is my paper with my supervisor, and I also use Hosper in this paper. So probably I think this is enough. Thank you, Dewanti. I'm sorry for all of the mistakes.
Thank you, Pandi, for such a very clear explanation on how doing Houseman and Taylor regression. And as mentioned by Pandi also, that this STATA, it's a very powerful program. So we really hope by doing this workshop, it will improve our capability as a researcher to do more research. And for now, let's proceed to the third trainer. He's my colleague and my senior also. He's the researcher at LAPE and the final year PhD student in the University de Limoges, France. So hi, Mas Aldi.
Hello.
Okay, it's good to see you. So Mas Aldi will be deliver his material for around 30 to 40 minutes. And for all the participants, we still invite all of you, if you have any question, please bring up the question by writing in the chat box. And so Mas Aldi, please present your presentation. Thank you.
All right, so let me try to share my PowerPoint first. Yep. Okay, so thank you very much, Dewanti and Dr. Ivan, for giving me an opportunity to deliver the material for the event study using STATA. So as what Dr. Tastafsian Riswandi said, that he is a still student, so me also, I haven't yet graduated from the university, so I'm still also a student. I'm still learning about the stuff from a lot of people. So in this section, I'm going to present to you about the event study using STATA. So it's more about practical, and I'm trying to touch a little bit about theory, but not that much. So it's more about the practical and how to do the event study using a STATA program. So before I do so, let me inform you about the STATA for the event study. So well, actually, STATA is a good program for any kind of data analyzing if you want. For example, like if you want to do with the GMM method, or for example, like the fixed effect, random effect equation, extra. But special for the event study, prior to 2012, there was no put-in command. So starting 2012, there was one. I don't remember the name. It was Professor Thomas Capresquet from the second. He developed a put command. Like auto command for STATA. So you can try to event study with STATA, but of course, there were also some limitation with that one as well. So as long as your data for the event study getting bigger, so the more the problem that you start having with the STATA, especially also related to the time that you're going to spend in terms of estimating the event study. All right, so let's start first about what is the event study. Of course, some of us may probably familiar with the kind of corporate action. For example, like if there was for example like a change in the key executive manager or for example there was a bank loan, or a company received bank loan from banks. So then when they announce that one into public, then market can react into a certain announcement. So the first is it's about the measurement of the valuation effects of a corporate action, for example, like a bank loan. It can be also merger and earning announcement. So it's more about the examination and the response of the stock prices during the period of the announcement. So in terms of doing the event study, you need to determine what kind of period that you're going to take, especially you need to rely also in the previous literature and in the theory for how long that it's going to last. Also, the event study also relies heavily on the market efficiency, that you assume all the information will be instantaneously reflected in the market, in the stock market, in the stock prices in the market. Okay, so here this is a graph for to give you the idea about the reaction. So before here this is the event. Here before there was no reaction, of course, but of course if there was because of the event there will be an efficient reaction where everything is incorporated. So it will cause something like this, but of course it can, the event also can lead to what they call the under reaction. So the reaction will be delayed into a longer period, and of course also it can lead also what they call the overreaction. It will overreact, can be positive, also it can be also negative. Depends on the what type of the event. For example, if there was large, filling large suit with damage to the company, but of course, in the other hand, for example, the company or the firms that are paying loan act positively in most of the case, or so basic objective of event study, of course, is there is an association between the abnormal stock price effect with the unanticipated event. So after that, of course, the research, they can draw the interference of the significance of the event, try to test whether the event is significant or not by looking into the statistic test, and then test itself. So basic assumption that you need to follow in the event study, of course, markets are efficient in that the stock prices incorporate all of the relevant and available information, and the newly refilled information will be reflected instantaneously into this. So it won't get delayed. So market knows everything about the information from the market. So the event, of course, is unanticipated. So you can conclude that the abnormalities are the result of the new reaction to the new information. So of course, biggest problem also, they need to, preserve the assumption of the event study. Of course, when you try to examine, there will be no confounding effects surrounding the announcement periods. So an example of the confounding effects is announcement of the dividends, as well as the announcement of the impending merger, like the company A is going to have a merger and acquisition. So that's during the announcement. If you try to examine the bank loans announcement effect on the firm stock prices, and there was a news also for the announcement of an impending merger, then the event that you're trying to examine will be confounded by this another event. So it cannot really reflect the real significance of the bank loan announcement. Also, for example, is signing a mature government contract, as well as a change in the K executive. Of course, is if there is a change in the K executive, of course, there will be a change on the prospect of the company in the future as well. Also, that's what I said before, it's a feeling of the large damage suit. So it's going to impact the event study that you're going to do. So let's start by step to implement the event study. Of course, first, before you're trying to do the event study, you need to define what kind of event that you're going to test for your event study. An example for this one, it can be, for example, you're trying to test whether or not a bank loan announcement will will lead to the market reaction for the firm's prices. It's related to the paper of Eugene Fama that the bank loan are unique in the sense that it give a signal to the market, because banks are we can assume that banks has more information compared to the market in particular, so it will give a positive reaction to the market. And then also once you define the event, you need to outline also a theory that explains the market reaction. Like you refer to the previous theory, it can be as well, for example, like in the case, for example, in China, if there is a pang reaction, but the pang reaction is loan from the government to the government, then it can be regarded as a related loan, or it can be regarded as well as the tunneling. So in that case, it can lead into the negative reaction for the market, because they will perceive that loan created by bank will be much more likely to benefit the majority of shareholders, but will at the expense of the minority shareholders. So of course, you need to identify a sample of the firms experiencing the event. If you're talking about the, for example, like the bank announcements, for example, because we're talking about banks, so it can you can, for example, take all the sample, for example, from the deal scans or Thomson Reuters related to the loan pricing and loan contract, for example, and as well as, for example, if you're trying to I mean, if your event is kind of related into, for example, like the effect of stress tests into bank stock prices, so you can try also to incorporate all of the firms or the banks that are impacted by the particular event that you're going to examine. So the important part as well, of course, you need to identify the event dates. But here it comes the problem as well. For example, if you're discussing about the bank loan announcement, you have what they call the contract date. It's the date where they sign the contract, as well as what they call the also the announcement of the announcement date. So basically, the date where they announce that they receive a certain amount of money from the banks as a loan, for example. So after that, when you identify the event dates, of course, you can determine the appropriate event windows. This is very tricky. At some point, you need to refer to the literature. So let me give you an example for the bank loan. Most of the paper, they will refer to 2 days period of the event windows. You can refer to, for example, a paper from Sepotan Tablian, or probably a paper from Huang et al. In 2011, discussing about the bank loan announcement reaction. So they use only 2 days event windows from T0 to T2. And you need to justify also its length, why it's 2 days, why it's 4 days, why it's certain days, this to that, why it's T-1 to T-2, T-1 to T2, for example, or T-1 to T1, for example. You can refer to the previous literature, or for example, if you take a look into the regulation from the Indonesian government, for example, required by the Indonesian financial authorities. So you can refer as well for that, that all of the corporate action should be published into public for the public listed firms. At the latest, it's 2 days of working days since the event take place in the first place. So you can refer that one as well. Why you justified, I mean, the way you justified, or why you say that the event will take place only for 2 days. Of course, you can also eliminate or adjust the sample. This is kind of the problem when you have a lot of, let's say, a lot of event or a lot of firms experiencing the event itself. But then, of course, when you try to take a look, the confounding factor, for example, like if you try to see out of 1,000 observation, you see you will see like 100 or maybe 150 firms during the announcement period. There was another event, or there was another news, for example, that will affect the announcement itself. So you can eliminate or adjust the sample, or sometimes even, for example, if you already determine the further step after doing the event study, for example, like you try to have a subsample, whether a big firms compared to small firms, or government firms compared to private firms, or government to family and institutional. Something that you can do separately the event study based on the ownership. Of course, you need to compute cumulative abnormal return. I assume that all of you knows already how to compute the cumulative abnormal return. And then you can test the significance of the CAR using several popular tests, for example, like Patel, test, and then also the normal cross-sectional test, as well as the special cases, for example, like Colari and Pinonen case, if you are working with the stress test in banking, because I will explain to you later why. And then the last, you try to explain the abnormal return based on the theories. I mean, you're not going to try to test an event and then you just suddenly said, okay, well, this is just because of this. I mean, and there was no underlying theory leading to that reaction at the first place. All right, so next, remain as well further about the event study. You need to decide the event windows. So you need to put it into your mind that some information about the event may have leaked out beforehand. For example, like there was a leakage of information that there will be a key executive changing, or probably there will be a leakage of information about the banks. I mean, the firms that will receive a certain amount of money from the bank as a loan, for example, or there will be a changing of a certain regulation that will have a huge impact on the certain industries, for example. So that's the things that you need to take into account first, especially to take care about the leakage of information. Sometimes as well, it takes time, for example, for the market to fully react to an event. For example, if you try to measure the merger and acquisition, it sometimes takes a little bit of time to understand or to get information about how many parties that are going to participate in this merger and acquisition, for example, as well as the potential acquirers and the other characteristics that might be revealed relatively in the long period. So of course, there is a trade-off between short and long windows. Of course, not all information about the event might be captured in the short windows. Information irrelevant to even more likely to be captured, of course, in the long windows. So for example, let's say if you take like T10, T-10 and T+10, then the longer you have the windows, then risk of getting a confounding effect from the other event is much more higher. Of course, the nature of the event should determine also the length of the event itself. All right, so this is basically the basic concept about the estimation period. I mean, because you're going to do event study, first you need to determine first the event windows. How long does it take the event to have a reaction in the market? And then as well, you need to define as well the estimation period. In that cases, you're going to use that one as a benchmark for the expected return without any event taking place before. So here, for example, in the estimation period, people normally do, for example, like 120 days. It can be like 100 days. It can be also 200 days. And normally, in these cases, people put like certain lag between the estimation period and the event windows. So it can be like 30 or 20 days before you start the event windows itself. So here it can be probably like T-2 or T0, for example. So it's 2 days or 1 day, or maybe probably the day that the event taking place in the event itself. And here it can be like T2, for example, 2 days, 2 working days after the event take place, or probably like 1 day after the event takes place. So here it's estimation parameter. Of course, when we talk about the abnormal return, is a function of the actual return minus the expected return. So that's the difference. This is the abnormal return. So of course, based on the banking paper and the latest trend of the event study banking paper, most of the people, they still use the cross-sectionality test to test the average event for the whole sample. But you can of course test individually the event, but people less likely are doing that now and nowadays. You can also use the Patel test with the adjustment of the standard error. But then a problem with the, I mean, moving from the cross-sectional to the Patel is what the Patel tried to offer to you is trying to solve the event index volatility when there was a higher volatility during the event period. But of course, it's still some of paper they still argue that they still suffer from the potential event-induced volatility, but then it does not tackle what they call the cross-sectional correlation. So let me show you an example for this one. It's, for example, like the event of stress test in banking industries. So when the government or the institution try to reveal the stress test on a particular country, for example, so that's a single event, but for the whole sample at the same time. So it is only one date for the whole sample at the same time. So what happened with that one is there will be correlation of the abnormal return between a company to another company. So in that case, most of the studies researching about the bank stress test, they're not going to use either cross-sectional or partial test. They will move directly to what they call the Colari test from Professor Colari and Professor Pinonen in 2010. So after that, because you are going to try to examine and try to calculate the abnormal return, of course, you need to decide what kind of market model you are going to use. Common method for market model for examining this market model, it can be the market model or market adjusted model. It can be as well the capital asset pricing model, or it can be a Fama-Friends three-factor model. So let's take a look into a market model. It assumes a stable linear relation between the security return and the market return, where the expected return is a function of the alpha plus beta, or sensitivity of the certain company to the return of the market plus error. So then you can use here in this cases, you can choose the return for the market. It can be like, for example, the S&P index if you're working in the US. It can be also the ITX. At some certain point, if you're working, for example, in like banks, for example, you can try to do some robust taking by creating an index of the bank stock market in a certain country. So that the abnormal return is a function of the real return minus the alpha plus beta of the market return, multiplied by market return. So A alpha is the average return of the firm compared to the market average, and P, as I explained before, is the sensitivity of the firm's return to the market return, and reflecting the market risk of this stock. So good point from this one is take both market trends and the firm's risk into account, and it removes the portion of the return that is related to the variation of the market returns. It reduces the variance of the abnormal return compared to the other model, and it just helps to capture the event effects. Next, it's what they call the index model. It's the older one. It's when the function of the abnormal return is the expected return minus directly by the stock market. I mean the market returns. So it allows for digital market movements and assumes that each firm has the same average return and risk characteristic market as a whole. So they assume that they have the same characteristic and average return. We have also what they call the CPIM. It was popular in 1970s, but nowadays people are much more using a market model. So CPIM is an equilibrium theory. Expected return of the security is determined by its covariance with the market portfolio, while the expected return is a function of the risk-free. The return of the risk-free investment plus the sensitivity or of the company from the market return minus the risk-free rate. So usually what people use this one is it can be the short-term government bond, and as I explained, it's very popular in 1970s. And the last one, which were very popular, was the Fama and Friends three-factor model. So in these cases, securities small firms and securities with higher book to market have had a higher return than what predicted by single factor model. So the function of the expected return is the risk-free rates plus the sensitivity of the firms multiplied by the risk of the return of the market minus the return of the risk-free rate investment plus the sensitivity of the firms into the multiplied by the HML, or high minus low, is the differences between returns between the firms with a high and low book market to factor a book to market factor. So it's kind of the ratio of book value of equity to market value of equity. So plus the SMP or small minus big. So it's the differences between return between small and large firm. So then you can conclude the abnormal return is equal to return minus the actual return minus the risk-free return from the risk-free investment multiplied by beta multiplied by the risk market return minus the risk-free investment return plus the sensitivity to the SML and plus to the sensitivity to the small minus big. All right, so actually I was supposed to share the how to do it in STATA, but I do not know if I do still have the time. But I can just show you how to, I mean, like briefly, and then we can do that after. So basically, how to do that at the event study with STATA, of course, we're going to use what they call the command event study 2. So this is the command. You can try to install it in the, I mean, using the SSC install event study 2. But here it was, I mean, if you're still using STATA 12 and STATA 13, I think you need to install that one, but I'm not really sure. But if I'm a second, if you're using the STATA 15, probably they already included that command into STATA, so you don't need to install anymore. So of course, first you need to prepare 3 different data. First is the event data. In this kind of data, it consists the event date, security IT, and also market IT. So security IT is the IT of the particular firms, as well as the market IT. This only if you're working with the cross-country sample. For example, if you're working with a sample from Indonesia and then Malaysia, and then you put also Singapore, Japan, extra. But if you're working with Indonesian firms only or Malaysian firms only, then you don't need to put the market IT because you're going just to need the one market return. So then you prepare also the security data. So it's the historical data of the certain stock. You put all the stocks in your sample, the historical data. So it consists what they call date variable. So it's daily data basis, and then you put also the security IT as well as the market IT if you're working in the cross-country section, and then their daily security return. Then you prepare what they call the market data. So it's the same. You put the date of the daily date historical market data, and then you put the market IT if you're working with the cross-country sample. And in case if you're using the pharma and friends model, so you need to put also the risk-free rate as well as the HML and SMB. And I believe here you can have it for free. I think if you go directly to the site of the Professor Kenneth Friends, so they publish for free databases for the risk-free rate and HML and SMB. So you need to calculate by yourself with this one. Right, so one thing that you need to do is you need to put everything into one folder because you're going to change the directory of the STATA into a certain folder, a designated folder, to be able to run the event study. And then after you change, of course, the directory, you can open the event data. You need to open the event data, and then you just run the event study with the command that I will show you later. And then voila, you will have the result of the event study. So I think that's all. Probably we can do that one after practice how to do that in STATA. So I will return back this to Dewanti.
Thank you, Mas Aldi, for the explanation on how doing the event study in STATA. And now we will have the question and answer session. We will have 1 hour, so maybe if we have a time, we can do the simulation on the 3 things that already delivered by the instructor. Before doing the question and answer session, I will also remind of the participant that the committee already provide the link for you to fill the attendance list for the purpose of the certificate. And it also will be the best for us to send all the material to you. So bagi Bapak dan Ibu, kami sudah menyediakan link di chat box. Harap untuk mengisi attendance list di sana sebagai dasar untuk mengirimkan sertifikat dan materi nanti. So I think we will proceed directly to the question and answer question. And then the first question is coming from Ahmad Maulin. It's addressed to Professor Low. So can the committee please unmute the three of the instructor so we can have interaction then? Okay, so thank you. And the question is coming from the Ahmad Maulin to Professor Lau. He would like to ask three questions. The first question is, I think he wants to write the paper. They have an idea that the relationship between X and Y is a two direction. Not only X is influenced by Y, but also is Y is influenced by the X. How the correct procedure to measure this, whether we only need to prepare the position in the model OLS to SLS or GMM, or we need to utilize Granger causality. For the second question, what is the strength and the weakness of the Granger causality? And the last question will be how the appropriate reason that our estimated rejection result truly capture the real impact of X on Y, not by the coincidence or the other factor. So Professor Lau, would you please to provide the answer for Ahmad Maulin?
Yeah, thank you for your question. So I think, yeah, I think it's an important question to be addressed. So yeah, I think I look at the question, yeah, okay, I can see the question as well. So the first question is whether, since your model have this, not only the X, the influence the Y, but the Y also influence the X. So this is like the simultaneity of two-way Granger, two-way causal effect. So mean we have this endogeneity issue here. So in this case, I would suggest that you use the GMM rather than the one that I suggested just now, because GMM can address this issue, but you need to be careful. Make sure that the N, the number of the firm, is more than 50 or 50, and the T is about 10, so that you won't have the too many instrument issue for your estimation, in that you diagnostic check like the over identifying restriction, and also the AR1, AR2 mean auto regression order 1, auto regression order 2 pass the result. Yeah, so you can use the GMM because this is the two-way simultaneity issue. Then, but you need to include the lag-dependent variable in your model, because that one will capture the dynamic effect, and make sure the lag-dependent is significant. Then the model is a dynamic model. If let's say the lag-dependent is not significant, then the model will be the static model. So when the model is a static, you can use the one I suggested to you just now, using the Peterson 2008, how to estimate the panel data. But the issue now, you also can consider Dr. MD, the method. Yeah, I think that one is still a good method to apply to handle this endogeneity issue. Yeah, and the second question is about how
What is the strength and the weakness of the Granger causality, Professor?
the strength and the weakness of the panel Granger.
Yeah.
Yeah, I think the panel Granger causality issue. First, they use the GMM to test, but they use the length of the independent variable. Then they restrict the length of the independent. Then to see whether the F test is significant to cause the Y, the dependent variable, but the method have the limitation. Then they move to the issue of these the homogeneity, and the issue of these can handle the heterogeneity and homogeneity. But after that, the issue come out, the issue is this cross-section dependent, mean that if you have panel, then this, whether this group of the country or the firm, they have this, they are correlated. I mean, the residual tend to correlate each other. So we have this cross-section dependent. So when we have this cross-section dependent, then we cannot use the old method like GMM, also the second author, I cannot remember, but recently there is a new method for this panel granular causality, but the limitation is only handle two variable only, like only can have X and Y, two variable to test for these two variable granular causality effect. So yeah, therefore you have more than two variables, so it's quite difficult for you to test the three variable. So far I noticed only two variable panel granularity, but you can consider the other one is a panel VAR model, okay, proposed by the one of the researcher. I think the name is from the World Bank, yeah, if I'm not mistaken. You just take the panel VAR. They also use the GMM to estimate, but they have this, they can handle the issue of the one panel VAR, they test for the panel granularity, panel causality. That one can handle more than two variables. Let's say 3 or 4. Then you put in the panel VAR system, and then they handle the causality. Then you can see the dynamic effect, which variable cause which variable. You also can do the panel, the impulse response function, and also the panel variant decomposition. And so mean that you can do a lot when you use the panel VAR. The code is available. Yeah, the PVAR code. Yeah, I have the code. If you want, I can share with you. So I have one paper. I use the panel VAR. You can test the dynamic causality effect among the variable, not only two, but you can have 3 or 4 or more variable to see the granular causality effect. And then the third question is how the appropriate.
Oh, the reason that our estimated regression is truly capture the real impact of X and Y, not by the coincidence or the other factor.
How the appropriate reason that our estimated regression result truly capture the real impact of X and Y, not by the coincidence. I think this one, I think we need to deal with the superior regression result, right? I mean that the two variable, let's say I assume only two variable, they have the meaningful relationship. So in order to test for the meaningful relationship, we need to make sure that they are moving together in the long run, not mean that they are coincident. Yeah, of course, you regress the CPI of Indonesia is increasing over time, it's an upward trend. And then Malaysia, let's say our Malaysia money supply also increasing over time. Then of course, when you run the regression, then they will be significant. Mean that the Indonesia CPI is significant determinant of Malaysia money supply. So this is called the superior regression result because they are trending over time. So we have this result. So before we test, they have a meaningful result, we must test the uniroot test to make sure that they have the meaningful result, really meaningful, not the superior. So we test the uniroot so that they have the same level of the stationary, and then they can avoid this superior regression. So I mean that I think that one is a long panel. You mean test for the stationary, but for the short panel like the GMM, you no need to test for the uniroot because we assume that it's already stationary because the sample is too short. No need to test for the long time series panel uniroot. Yeah. So I think what you mean here, I think is the superior regression. So in order to make sure that they have the meaningful, of course, we must based on the theory, the variable have the relationship. Yeah, based on the theory, based on the literature, then can avoid the superior regression result. Yeah. So I think that's all my answer. I hope I answer your question. Yeah.
Thank you, Mr. Ahmed, for the question, and I really hope that the answer will be satisfied, the question. And let's move to the second question from Anna Purwa. It's also addressed to Professor Lau. When we have to use the fixed effect or random effect instead? Thank you.
Okay. When we have to use the fixed effect and the random effect. Yeah, so I think this is a important question. So yeah, we need to test whether fixed effect and the random effect, how to differentiate. Okay. Yeah, I think before that we need to know what is the heterogeneity, mean that our data set have the different characteristic, mean that they have a different, for example, let's say the country, they can have the different characteristic heterogeneity, but this heterogeneity, they are unmeasurable, mean cannot observe or cannot measure, therefore we need to test. So normally we'll test this heterogeneity or unmeasured effect using this Bush-Pagan LM test to test for the presence of this heterogeneity. So in the STATA command, after you run the random effect, you run one equation using the xtreg, then y, then x, then comma, re is for the random effect. Then after that, you use the xt test 0, and that one is the Bush-Pagan LM test. So the command is xt text0. Yeah, so the one is to test for the Bush-Pagan, to test for the heterogeneity. So if the result significant, mean they reject the full OLS, mean that they conclude, they support the random effect, mean that the data set have the heterogeneity, mean they have the specific effect. Therefore, the pool OLS cannot be handled because it will be biased. Then only the random effect and free effect can handle these two, this heterogeneity or specific effect. So the question is, when we have to use, so of course, when you want to use the free effect or random effect, we need to test whether, yeah, the first we have identified heterogeneity, mean there is a specific effect. Okay, then we just ignore the pool OLS. So now we can only choose either the free effect or the random effect. Yeah. So in order to choose the free effect and the random effect, one way we can use the Houseman test to test the fixed or random, which one is more appropriate. And then I need to let you know the random effect, there is no correlation between the error term and the regressor. Just now, Dr. Andy has mentioned this. And the fee effect, they allow the error term, I mean the error term is part of the specific effect as well. Mean the error term have a correlation with the regressor. Mean the error term have a relationship with the x, independent variable for the free effect. But for the random effect, they won't allow the relationship to be occur. Mean the error term and the regressor no relationship. So of course we can test using this Houseman test. So the Houseman test can identify is there any relationship between the error term and the regressor. If there is the relationship, then they will support the fixed effect. No relationship, then they will conclude the random effect is more appropriate compared to the fixed effect. Yeah. So yeah, then we need to use the Houseman test to test the random or fixed. But just as I show you, you can use the xtreg command, then comma fe, right, the fixed effect. Then you look at the last row, the F test. If the F test is significant, then this is indicate that there is a fixed effect. Yeah, so you can use either the Houseman test or you can direct observe from the fixed effect output. Look at the last row, then the F value test is significant, mean that there is a different intercept. So the fixed effect had the different intercept. We can draw the diagram to see which country have the highest intercept, which country has the lower intercept by using the diagram. But for the random effect, we cannot draw one specific diagram. Why? Because the random effect, they draw the sample randomly from the huge population. For example, you draw one sample, then it's a random, then you estimate this, you get this result. And you draw from another sample, then you get another result. So there is no figure to draw the random effect compared to the fig effect. The fig effect, you can see they have the different intercept for their linear line. But for the random, no diagram to show for the random effect model. Only have the fig effect diagram. Yeah. So normally my student also ask me, so why we cannot draw a random effect diagram? Because why? The random effect is a random. We have no specific to draw the diagram. Yeah. So when we have to use, you can use, but you need to test which one is more appropriate, more superior or appropriate to use. Yeah. Not mean that you always support the fig effect always. Sometimes can be the random. Yeah. Okay. So I hope I answer your question. Okay. All right.
Thank you, Prof. Lo. And I think that question is coming from the Nur Imama. It's also addressed to you. Do we need to create the dummy variable in our data set? As I know, when I use the if-use in our running regression, the dummy indicator shown in the regression output when we choose fixed effect without creating a dummy variable in our data set. Thank you.
Okay, this is the interesting question. So yeah, I think do we need to create the dummy? But okay, yeah, when you use a STATA, we in evil or even evil, I think evil, because normally I use STATA. So normally I just use the command to create the dummy. Yeah, the STATA can create the dummy, the time dummy, and also the cross-section dummy, the firm or the country dummy. So we no need to create in our Excel file. Yeah, because waste our time. Because why? Because yeah, we no need to use our Excel to create the dummy, but the STATA automatically will generate for you the dummy, whether the country dummy or firm dummy or the time dummy. So we no need to generate in the Excel or even in the eView, because I think eView, I haven't used the eView to generate the dummy, but I believe the eView also can be used to generate the dummy. But STATA is very quite straightforward. There's either the time dummy or the cross-sectional dummy. You just tabulate the ID, then comma, generate the end dummy. And the year time dummy, just tabulate the year, then comma, generate in the comma T dummy. Then they will generate for you the time dummy and also the cross-sectional dummy. So you don't need to create in our Excel, waste our time because we have no time to do the work, right? Yeah. So we no need to do it in our Excel. Yeah. I hope I answer your question, the email now, right?
Yeah.
But yeah, I think the question is dummy no need to Then you say the regression output when we choose fixed effect without creating a dummy variable in our data set. Yeah, because why? Because in the you can mean that this one is the least square dummy variable. Yeah, I think you refer to the fixed effect got two. One is within within group, and the other one is a least square dummy variable. Least square dummy variable command is the request, but the within group the command is xtreg. Yeah. So what you mean? I think you use the least square dummy variable. You create the dummy because you want to see the country or the firm their intercept, right? So which country or firm have the highest intercept? Then you can use the least square dummy variable, because the least square dummy variable and the within group fixed effect both will give you the same result, but the additional one is the least square dummy variable give you the intercept for each group of your analysis. So let's say you want to see the East Asia, whether Singapore or Malaysia or Indonesia, which one their intercept is the positive or negative, then you can use the least square dummy variable to see the intercept. Yeah. So you need to create the dummy if you want to use the least square dummy variable. But of course, you can generate the dummy in the STATA. You no need to do it manually. Yeah. Okay.
Okay, thank you, Prof. Lo. And the question is also addressed to you. Pak Harmadi asked the question about when we use a multiple regression and we choose the robust, we can ignore the classical assumption. Why we can do that? So please provide us some information.
Okay, yeah. Because based on the robust command is the STATA, the robust is already addressed the issue of this heteroscedasticity and also this serial correlation. So because the standard error is a robust standard error, so when the standard error is a minimum standard error, mean they have adjusted the standard error, then we can rely on the hypothesis testing. Then the result, the conclusion is unbiased. Okay. For example, when you have this problem, the hetero problem or autocorrelation problem, then our parameter mean the beta still can represent the true parameter. Mean the beta one still can be reliable, the beta, the coefficient, but the standard error no longer reliable, then we need to correct the standard error because the variant no longer the minimum variant. Therefore, we correct for the robust standard error using the robust command. Then the standard error is the robust standard error. So the t-test is the coefficient divided by the standard error. So the standard error has been corrected. Therefore, the t-test, the t-statistic will be a correct one. Then you can make the conclusion, your hypothesis testing, yeah. And then one more thing is the variance is no longer minimum. Then the standard error is not the minimum, not the reliable standard error, but the coefficient is still represent the true parameter of the population. Mean the beta 1, beta 2, their coefficient still the still unbiased, yeah. And then after that, in terms of hypothesis testing, yeah, mean when you have a correct standard error, then your hypothesis testing will be more robust compared to without addressing the issue of this standard error. Yeah. So I hope I answer your question. Okay, Pak Hamadi. Yeah.
Yeah.
Yeah. And
So thank you, Prof. Lau. And the next question will be addressed to our second instructor, Pak Andi. We have some question to you. Okay. It's the question is coming from Pak Ahmad Maulin. He questioned two things. The first one is how if our estimated results are very sensitive, significant, and sign either positive or negative related to how many and what the instrumental variables are we used. And the second question is how to make sure that our instrumental variable are appropriate or over-identified.
Okay, thank you very much for the question for Pak Ahmad Maulinova. Okay, so Professor, in my mind, if our estimation results are very sensitive, so there is several possibilities. And in our estimation, in our equation, it could be there is a problem called omitted variable bias. So meaning that we have a variable that actually should be there, but we don't have it in our model. So in this case, if this variable is very significant, the impact in the estimation that we want to so if we don't put this variable in our model, so possibly the result will not as our expectation. The second one, if our estimation result are very sensitive, it could be significant, it could be insignificant, and etc. Or it could be positive, and when we try in the by using other controls, it become significant for them. So there is a problem of, for instance, a multicollinearity. So we have to note that the multicollinearity problem is not only related with our main variable of interest. So let's say our variable interest is x1, but if in our model there is a multicollinearity problem between variable x2 and x3, so it could also interfere the positive or negative sign in our main variables. So the multicollinearity thing is not only related with our main variable, but it is also for other variables. And this kind of thing, we have to very sure that if we see from the literature, many in the our friends in the, for instance, in other than finance, for instance, in the multivariate data analysis. So use correlation coefficient, it is considered as high if it is more than 0.8. In finance, the rule of thumb is kind of different. Usually, we have to be worried. We have to make sure that in the correlation metric that we have after we make a correlation coefficient. So we have to make sure that our all of our variable, they don't have a correlation coefficient more than, for instance, 0.4 or 0.5, because 0.4 or 0.5 in the field finance, it is already considered as high. And the other possibilities, if our estimation results are very sensitive, it could be also because of external use. So I read many times paper, manuscript, if they're submitted to the journal. So if I see from the descriptive statistics, I still see the maximum and minimum values, they are contain extreme values. So we have to make sure, because before regression, we have to make sure that our variable, not only our variable of interest, once again, not only our variable of interest, all variables are free from extreme values. So this is several things that makes our result possibly very sensitive. And then the second question is that how to check if our instruments are correct. Well, it depends in which estimators we use. If we use two-stage least square, so we have to fulfill two things. There is what we call instrument exogeneity and then instrument relevance. Instrument exogeneity, we have a test in STATA. It is called Hansen test or Hansen statistic. So it will make sure that our main variable of it will make sure that our instrument, it is uncorrelated with you, with you. And the second one is that instrument relevance. Instrument relevance, it means that it is related with the strength of our instrument. So usually in the two-stage least square, first stage, in the first test of regression, we have a F-test over there. And then if the F-test is significant, we could consider that our instrument are relevant or our instrument are strong enough. And if we use another estimator for instance, the GMM or maybe Hausman-Taylor regression, the procedure will be different, because the Hausman-Taylor regression and the GMM, the instruments are generated from the system itself, from the variable that we have. For the GMM, is using the leg of the variables, and from the Hausman-Taylor is also using the combination of like variables and the time variant and time invariant variables that we have. So the procedure is slightly different. I think it's my answer. I hope that this is and probably Professor Law could add some explanation. Thank you.
Thank you, Pani. So, Prof. Lo, maybe you want to have another explanation on how addressing this question regarding the instrumental variable.
Oh, okay. So I think yeah, the second question, how to make sure that our IV are appropriate, not over identified. So actually, when I study, my supervisor mentioned to me that there is no one actual criteria to ensure that our instrumental, wherever they are valid, as long as we pass the Sargent test or this Hansen test, then mean that we pass our instrumental this over identifying test. So mean that we have no more issue of this like over identify issue, as long as the test pass the validity, then our instrument they are valid. But before then, to make sure that our instrument must be highly correlated with the X variable, the one that have this problem of the endogeneity, but there is no highly correlated with the error term, so that they can fulfill the good instrument. Yes, to as a good instrument mean that the variable, the instrumental variable must be correlated with the X variable, let's say X1, but the instrumental variable are not the correlated with the error term. Therefore, they fulfill the criteria to be the instrument. Like for example, in our, I think the famous example is the schooling. I mean the student, our earning based on our income based on the schooling, then the error term can be our ability, right? Our skill, our ability, that one captured in the error term. So our schooling, yeah, that one is highly correlated with our ability. The ability is one of the captured by the error term, because ability is very difficult to measure. So in the literature, they try to use our parent education, mother or father education, because they assume that if if let's say a person that have the higher education, of course, due to their parent also have the receive higher educated people. So they measure the instrument using their parent education, yeah, mother, father, or their education as an instrument for our education, because then these have no correlated with the ability. Yeah, so this is a example used in any econometric textbook to explain whether the parent education is a good instrument for our schooling. Yeah, so normally you can see any in any example, this is what they try to explain, that as long as no highly correlated with our ability, but the parent education is highly correlated with our schooling, then the parent education is a good instrument, yeah, to our model. And then of course we need to pass the test of the test. If the test is passed, then yeah, the Hausmann and also the Sargent or Hansen test, then will pass the validity of this instrument. Yeah? So I think I can add this D. So I think Dr. Andy has answered the question as well. Yeah, thank you. Yeah.
So thank you, Prof. Lo. And so let's move to another question that will be addressed to Mas Aldi. Okay, can you unmute your first?
Yes.
Okay. So the question is coming from Ibu Ratna Ningrum. She questioned about what is the most suitable car return model for the emerging market.
Okay. So thank you very much for the question, Ibu Ratna Ningrum. So, well, basically, if we say what is suitable for the emerging market one, we're not really sure which one is better. But of course, what problem is here with the study with the emerging market is there will be question whether or not the stock market that we are examine it's frequently traded in the market or not, and how big also the stock market itself. It will be a bigger question compared to the market model for that we will use to calculate the abnormal return. But of course, based on previous studies in banking, for example, most of the studies now they use only market model, except those who study in the stress test banking. Most likely they modified the market model using the Newton and Wagner in 2011. They put what they call a dummy if the event's already 10 days after the announcement, something like that. So it takes again, it refers to the previous literature. If the previous literature that you follow, they use only market model, so then we can simply move to market model. Because point with market model is with the return itself, the expected return itself, it's a function of the alpha or the average firm's return compared to the average of the market return itself, plus the sensitivity to the market return. A problem is if the sensitivity itself is not significant, so then probably the problem more itself in the index that we use or market index that we use to measure the expected return. So in that cases also, so for example, if you study in Indonesia, for example, and you're studying the banking sector just in Indonesia, so instead of using only the IDX, so you can put in the robust checking, you build your own index for banking stock prices in Indonesia. So you use that one in order to get to be able to reflect better the sensitivity of the firms to the stock market. So I mean to the market itself. I hope that answers your question.
Oh, thank you, Mas Aldi. Clearly answered the question. I hope also it's also satisfy Ibu Ratna Ningrum. And let's address to, I think it will be the last question, and it addressed to Professor Lau. It's coming from Pak Supriyadi. The question is about, so he has a specific question regarding his research. Pak Supriyadi using panel data with N is 419 and the time is 8. He already have one invariant variable. After performing the unit root test, he found that one of the independent variable was stationary at leg 1, while the other variables were stationary. So the question is, what is the most suitable model used for this research?
Okay, yeah, thank you for this question. So yeah, the N is 490 and the T is 8. So I think this is considered a short pen, but it's not because it's short T. And then I think you no need to run this uniroot test because this is considered the short T pen. So unless you have about 20 above T, then you can test for the panel uniroot. Yeah, since it's only 8 then and the N is large, 490. So I would suggest you to, if you want to test the impact or relationship, then I would suggest you to use the GMM. Yeah, it's a, let's say your dependent. What is, may I know the dependent? If the dependent variable is influenced by the past, for example, the investment, the sales, our economic growth, or the capital structure, the debt, or leverage, or the equity, and also the investment, the weight. If let's say the dependent variable will be affected by the past, let's say the last year, Yeah, I say this year performance, this year sales will be depend on the last year performance. Then this will be the dynamic characteristic. Then I will suggest you to use the GMM, yeah, because I think if let's say we have this specific effect, GMM can remove the specific effect by taking the first difference, then they all are the same. So all can be estimated, become fair now because no specific effect in the data set. Because the issue is your T is 8 only, 8 years, so you no need to present the panel unit root test. Yeah, because panel unit root test only can apply when our T is large. Let's say about 20 years and above. And yeah, so I think in this case, in your case, um, your structure, the data structure is suitable for the short panel. N is large, T is small. Then I would suggest you to use the GMM estimator rather than using the time series. Because the time series, this one is not the time series. Because it's the time series, then the T is large and the N is small. And then in your case, it's the other way around. Then the GMM or the one that I shared today is suitable. If let's say your data is a firm level data, and then you think that your dependent variable is not the dynamic process, but it's a static process, then you can consider the one that I shared today. Or if let's say the dynamic, your dependent is a dynamic variable, then you can consider the one that I shared last week. Yeah, the GMM estimation using the system GMM estimator can answer your objective. Yeah, because I think if you can let me know your dependent variable is what is the variable, I think is a dynamic variable, then you can use the GMM. Mean that you include the lag dependent in your one of the requests in your independent variable list. Yeah, so then you can test. If let's say the lag dependent is significant, mean that it's a dynamic process, not the static. If not significant, then will be the static. Then you can use the one that I shared today, yeah, for your estimation. So, but no need to test for the unit root test because the T only 8, then it's not suitable to test for the panel unit root test. Yeah. Okay, so I hope I answer your concern so that you can, but of course you can email me, yeah, to get to let me know. So my email is I think from the first, I think the slide, I think I mentioned my email, yeah. So of course you can search my name, then from the website, the faculty website, you can see my email. Then you can email me, then I will answer you. You let me know the dependent variable so that, yeah, then will be more, I can more confident to answer your, you know, the dependent variable, whether it's a dynamic or static. But I think for your case, no need to test for the unit root test, yeah, because the T only 8 observation only. So I think that is what I want to respond, yeah. Dianti, yeah.
Yep.
Okay, yeah.
So thank you, Prof. Lo. And I think we are about at the end of the workshop session. So with before we end the session, I would like to invite our 3 instructors to maybe give like the final conclusion on this workshop. So the first, Professor Lo, maybe you can deliver like the last statement for this workshop.
Yeah, thank you, Auntie, and thank you, everybody. Yeah, so yeah, the panel, just want to share the panel data we can divide into 2. One is the short panel where the T is about 10 or less than 10, but the N is large, mean more than 50. Yeah, so therefore it's a short panel. But for the long panel, mean that our T is about 20 years and above, and we have less than 20 for the N. So mean we have 2 data structure. One is a short panel, the other one is a long panel. So we need to be careful because the different structure will have a different method to estimate. Yeah, so we need to identify the correct method to estimate the short panel or long panel. Yeah, so and today I share this the standard error, that one is can be applied in the firm level data, especially the banking, finance or accounting firm level data. But that one is a static model, it's not the dynamic, because we do not see the lag dependent appear. But yeah, if let's say you have the lag dependent, then you need to use the GMM, and because it's a dynamic model. So so today I share the static, but the fee effect, random effect, that one also only can handle the static, they cannot handle the dynamic. Yeah, therefore you need to identify whether the model is a static model or the dynamic model, and then after that make a decision whether which estimator, whether it's a long panel or the short panel, then apply the appropriate technique so that our work will be more uh, accurate, so that nobody can question our estimation technique. Then then will be more, the reviewer or the examiner, they will satisfy our work. Yeah, so they have no more further question to comment, because the estimation has been really implemented well, and also carry out the empirical research well conducted. Then no more criticism from the editor or reviewer. Of course, the write-up must be good, yeah, for in order to publish in the good journal, right? So that's why that's all. The only thing I would like to share. Okay, thank you.
Thank you, Prof. Lo. So the next conclusion will be delivered by Pak Andi. So please, Pak Andi. Hello, Pak Andi.
Yes.
Okay,
Yes.
so please.
Could you hear me first?
Yeah, it's clear.
In Indonesia, usually for weddings, and the question is usually is like this. They have a data, for instance, with several observation, and then after that they want to test whether they want to use OLS, random effect, or fixed effect. Well, I'm continuing what Professor Lau have said, that if the form of our data is panel, so actually there is no need to test whether we want to use or use fixed effect. Sorry, if we want to use OLS or we use panel data regression, because if our data is panel, so we have to use a panel data regression, except if there is some specific reasons that force us to use OLS regression. And then, well, the choice is then rest to true if our panel data is dynamic, as Professor Lau said, so we can use like a GMM, but if it is static, so we could use fixed effect or random effect. To use if invariant, sorry, if there is a specific time invariant unobservable characteristics from the model, so actually we don't need to use Hausman tests, so we can directly use fixed effect regression. That's why in many paper we could see that they never use Hausman test to determine which fixed effect or random effect estimator that they want to use, but they usually directly use fixed effect regression, or they use directly use GMM regression, because the choice is based on the theory in the literature that the data containing unobservable characteristics or not. And then the thing is that I already explained to if the Hausman test said that we have to use fixed effect regression, but we don't, and then our main variable is time invariant. So this one of the solution is that we could use Hausman-Taylor regression. Hausman-Taylor regression is actually also panel data regression, but it's also instrumental variable regression that could be used in order to make our time invariant variable still be accessible in our estimation. I think this is from me. Thank you very much, Riwanti, and thank you very much for all of the participants.
Thank you, Fandi. So last but not least, Mas Aldi, please deliver your statement.
Okay, thank you very much. So let me sum up about the event study. So key point in event study is defining your event, what kind of event that you are going to test. And of course, this will determine what kind of test that you're going to do. Either you can use the cross-section or patel, or because there is a significant difference as well, the other one with the polarity test. In case if you have the single event for the whole market, for example, like a stress test, so it will determine also a test that you are going to use, as well as kind of market model that you are going to use, following like Nichman and Wagner in 2011. So first you need to be sure on the event and then also on the sample. So that's all I think what I can sum up from the event study. It's easy, but it's a little bit tricky. Thank you.
Thank you, Mas Aldi, and thank you very much for all the participants. I would like to deliver our gratitude to all of the three instructors, Professor Low, Pak Andi, and also Mas Aldi. Thank you very much for the time and provide us such a very insightful material. And for all the participants also, thank you very much for being committed to join in the session until the last. And I'm pretty sure that 3 hours is not enough to mastering all of the material that we already discussed today. But as Professor Low mentioned, that he already put the email, so the participant, if you have any further question, you can directly contact to Prof. Low regarding the question. And for all the participant, for the certificate and material, we will deliver to you after you fill in the link that we already provide in the chat box. And that was the end for the second workshop of WCP Universitas 11 Maret, STATA for various empirical studies in finance, banking, and accounting. I'm Dewanti Chayaningsi on behalf of the organizing committee. Once again, I want to say thank you very much. And do not forget to follow us in our various channels of our social media to follow all of the activity provided and organized by ONS Banking and Fintech Center. So I'm Dewanti Chayaningsi. Stay safe and hope to see you in the next event.